3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really
totally
is.
agree with
Level. It really
totally
is.
agree with
Level.
And bam, there's the radius of the Earth.
Horizontals everywhere you go.
Always
Yeah, but
parallel.
if I draw a straight line across an A4 bit of paper,
Yep.
that's horizontal. But then if
Well, I don't know.
If
I turn the bit of paper, that then becomes vertical, does it not?
What, if you're turning it on a table?
Yeah.
Yeah.
No, it would. I don't know. It depends. Is the table horizontal? Have you leveled the table?
If the table would be horizontal.
Okay. Now, the stack of paper, would that also be parallel with the surface of the table?
Yeah.
Right, okay, then any line drawn on that piece of paper would be on a horizontal plane, wouldn't it? No matter what shape. And if you turned it, right?
What if I stand the paper on its end? Is it still horizontal then?
Would it be perpendicular to the surface of the table?
Yeah, I accept you can have horizontal lines, yeah.
Okay. So when you stood that piece of paper up, just to be more specific, because we do like to speak mathematically and be precise with what we say. When I just asked you, was it perpendicular to the surface of the table? Is that what you meant by stand it up?
Yeah.
Okay. So then, yes, it would be vertical if that was the case, because it would be perpendicular to a horizontal plane, would be vertical, wouldn't it?
Yeah.
So we do live in reality, right? We're of a good understanding. Do you want to see a proof that horizontal is a line of unlimited length? And how to extend that horizontal straight line in reality?
Well, I don't think I've ever come across anything that says that a horizontal line has any particular restrictions. That it can only be a certain length. That it can only be a certain distance from a certain point.
Oh, yeah.
Yeah.
Dead right.
Yeah, Rumpus said it could be infinite.
Yeah, it is definitely infinite. It's a horizontal plane, is of infinite length. But I'm just asking you, would you like to see a proof for that? Or are you happy with in your knowledge that a horizontal is of unlimited a plane?
Yeah. I'm happy with that.
Okay, so you don't need to see a proof?
No.
Okay. So if I was to say to you then, level is a straight line on a horizontal plane, you'd be happy with that? You wouldn't need to see a proof for such a statement?
No, I wouldn't need to, no.
Okay, that's good. I'd watch out. Don't tell anybody you've just said that. They might call you. They might call you names. You could. I think you could be Team Nug now, though. I think definitely freeing up a nugget for you.
Nugs, not thugs.
So when... Oh, I don't know. Puts you in a bit of a...
Oh, hold on. Give me a minute.
Okay. You got an incoming call from... I was really hoping to hit the whiteboard there, but I mean, didn't even want to see the proof. That sure he was of his knowledge that level is a straight line on a horizontal plane, that he doesn't even need to see a proof. He must have one of his own.
Sounds like a geometrist to me.
I'd be keen to see what his proof is. You know, how
I
he
wonder what his
sees-
name is based on, though. Highlander. Is that based upon a vertical change from sea level?
Oh, he's gone. He's gone.
He got the call.
Yeah,
That was Rumpus.
I think, yeah.
Abort. Abort.
Did he just say, did I just say the level is straight line? Did I agree to that? What the fuck did he do? He tricked me.
Get out of there! He tricked you.
I mean,
5-minute timeout
like,
today.
if I was talking to an astrophysicist, right, and they were telling me something about black holes, say, then I'm not going to ask for proof, right, because it's not something that the mathematics that are involved in black holes and astrophysics is out of my league of understanding. So I would just have to accept that they're a professional in their field and then they know what they're talking about.
Yeah, but what about, like, if I was to say to you, there's a proof in mathematics that a triangle only has 180 degrees. I mean, I can show you the axiom, triangle axiom. I can show you a proof, even though you're not meant to be able to prove that. But I mean, I guess in order for you to be able to say 180 degrees, then you were going beyond the axiomatic of Euclidean geometry, and you're entering a realm of adding degrees in there, right? A number thing. But I mean, like, you wouldn't need to see the proof, would you, that a triangle only has 180 degrees, or would you? Have you ever seen it, Highlander?
What, a triangle with more than 180 degrees?
No, I said, have you ever seen the proof that a triangle has only 180 degrees? Have you ever seen that?
But a triangle can have more than 180 degrees in angles.
But like, so you've never seen the proof that a triangle can only have 180 degrees then? Right, there's loads of them. You can put it out anywhere.
But I know that's not true because I've seen triangles with more than 180 degrees. So if somebody said to me, you know, triangles only add up to 180 degrees,
Yeah.
then I can say, well, no, because I've seen the evidence that contradicts that.
So you saying that you could find a proof that triangles have, was it more or less than 100? Because if I can find you a proof of a triangle only having 180 degrees, or an axiom even, do you think you'd be able to show me a proof that it's false, right? Do you think you could disprove my proof from mathematics about a triangle?
Show me a triangle with the angles add up to 180 degrees doesn't mean that all triangles add up to 180 degrees.
Yeah, it does. It's just like there's a proof. If there's a proof within mathematics that a triangle has only 180 degrees, then, like, that's what it is. It's a mathematical proof that triangles only have 180 degrees.
Right, so you've shown me, let's say you've shown me 50 triangles, and every one of them add up to 180 degrees in angles, right? But then another mathematician comes along and says, well, look, here's another 50 triangles where all the insides add up to more than 180 degrees.
How would they do that? Where would this mathematician be that just says that, or are you just like sort of imagining it?
Well, I know triangles can add up to more than 180 degrees.
How? What? How? How do you know that? Where's your proof for such?
All you have to do is draw a triangle on a sphere.
Ah.
If you draw a triangle on a ball, the angles will add up to more than 180 degrees.
But that's not a triangle, is it?
So what is it if it's not a triangle?
Do you know the definition of a triangle?
Yeah.
Go on. So what have we got for a triangle? First off, I'll give you the axiom, right? You might have heard this before, you might not, but listen. It says that if a straight line falling on two straight lines, so you've got one straight line falling on two straight lines, so that's three straight lines, right? Makes the interior angles on the same side less than two right angles. The two straight lines, if produced indefinitely, will meet on the side which are the angles less than two right angles. Do you want me to get on the board? I can show you that if if that makes it any, because it's a bit long-winded, that. I'll see if I can find, that's in the debate discussion. And I'll see if I can find what about that one? Is that there you go. Can you see that?
No.
It's a triangle.
Yeah, that's a triangle. Yeah.
Okay, so you see the triangle ABC, or the internal
Right.
angles ABC, and the line AC is, like, we'll call that the baseline, and those two little chevrons, the arrow chevrons, means if you produce a parallel line along the top, then the angle at A, because the vertical angles are always equal when you get a line bisecting a parallel lines. So the angle at A is equal to the angle at 1, and the angle at C is equal to the angle at 2, and B is also a common angle, so that 1, B and 2 all add up to 180 degrees along that, along that straight line, although it's not really an angle of 180 degrees, but that shows that all of those angles of that triangle always add up mathematically to 180 degrees. Now, there's only, well, you can't actually do it, because in order to make an angle is the inclination between two straight lines. So you need a triangle. You should know that. You need three straight lines to make a triangle. So therefore, any triangle, always, proof of it, also it's axiomated. They're that certain of it, they didn't even need to do a proof for it.
Right. So if I show you this, you would say that that shape in the center is not a triangle.
Absolutely. Would you say it's a triangle? It doesn't look like a triangle to me. It's got three curved sides. And where would you have the angle?
It's triangular in shape.
But where's the angle, though? Where would you measure the angle? Because you need two straight lines. At what point?
At the points of where the normal points.
That's
that's
hyperbolic geometry, right? That's an asymptotic, isn't it? At that point there, that's an asymptote. It's a sort of a point where they never meet. So there's no angle there, is there, to measure? And even if it was, you wouldn't be able to add those angles and get more than 180 degrees. I mean, that's definitely not going to be a proof of a mathematical triangle having more or less than... I mean, that is... that's hyperbolic, if you didn't notice. Right? You do know that. That's non-Euclidean. Can you show us the definition of a triangle in hyperbolic geometry?
Right. Here's...
You could have had the angels and the demons. See if I can find that. It's much better than that one. There you go. There you go. 1960. It's Escher, innit? Oh, it does say on that one that you give us there, Wikipedia. Nice try.
Yeah.
It says, in a Euclidean space, the sum of angles of a triangle equals the straight angle 180 degrees, pi radians, 2 right angles, or a half turn. Triangle has 3 angles, 1 at each vertex, bounded by a pair of adjacent sides. That was good. So is that your proof that triangles can have more? Because that seems to say that triangles have 180 degrees. So, and again, oh, that's Bloods, is it? Yeah, it's Bloods putting that stuff in there. Triangles, 3 straight sides, 180 degrees, Highlander. If there's a proof within mathematics for something, you're normally best off not bothering, like trying to disprove it, right? But you went to it straight away, Highlander. After being told that there was a proof for a triangle having 180 degrees and it being axiomated. You said somebody had told you something about... Something, was it? Who was it that had told you that?
What do you mean, who was it told me?
Who was it that told you that you could just dismiss a mathematical proof? Must have been some really clever person, surely, because you just dismissed the mathematical proof of a triangle.
Yeah, but you're the one that, as soon as the lines aren't straight, immediately state that that's not a triangle.
Yeah, because an angle is the inclination of 2 straight lines to one another. And a triangle, three, has 3 of those. Thus,
So
3 straight sides.
So you can't have 2 curved lines come to a point and that would be an angle.
Absolutely not, no. An angle is the inclination between 2 straight lines, right? How do you measure an angle? It literally is an angle, is a circle divided up into 360 equal parts with radius lines. Right? A radius line is definitely a straight line, isn't it? Highlander. That's an angle. So you need 2 straight lines to make an angle. And to have 3 angles, the minimum amount of lines you have is 3. A triangle. It's a very well named shape. One of the most fundamental shapes that we ever have. Without it having a triangle, without a triangle having 180 degrees, we wouldn't be able to perform trigonometry.
Right, so you're saying that the we can't work out what the angles are of these two curved red lines.
The ones where you've got an angle there. Can you see that? That's straight lines. The angle that you've got marked, theta, is marked in between two straight lines. You've done, somebody else did this the other day. I can't even remember who it was. He showed us a picture of straight lines and an angle, just like you have. But somebody else has drawn some other curved lines on it. And you don't assume that that angle there in between those two straight lines is an angle between those two curved lines, do you? When it's quite clearly two straight lines needed for the angle. It's quite a popular one, that. Who is it that's told you this, Highlander? I'm keen to know. Because I wouldn't mind having a chat with them. It sounds like a bit of a better... Because you didn't just make that up, did you?
Well, there's another example.
Yep, straight lines. Even there's got a triangle there.
Yeah, it's got a triangle underneath the two curved lines. But the two curved lines still make an angle.
No, the angles between the two straight lines, again, quite clearly shows two straight lines there, again, with the angle marked, theta.
I'm the only keen here.
Can you not see that? Like, there's quite clearly two straight lines in order to make
that last
for him
one
to
he
put that
posted
angle.
is the triangle, isn't it?
Yeah.
Yeah.
With them curved lines right at the apex.
Yeah, that's got nothing to do with it. That's still just a triangle underneath some other lines.
Yeah, they formed the triangle where those intersecting lines were, and then measured the angle from the top point of the triangle. It's just one of the angles of a triangle with straight sides.
Yeah.
I'm quite keen to understand where you got this from, Highlander, because I've been saying this for quite a while. It's pretty simple. An angle, in order to measure an angle, you need two straight lines. It's a must. It's a prerequisite. A necessary antecedent of an angle is two straight lines. I quite like that. That sounded quite nice, that. Using necessary antecedent, even though necessary is not needed. Who was it, Highlander? Come on. Who's your head honcho? I don't think he's a globe geometer, is he? Just trying to confuse Euclidean geometry in the minds of the globe defenders. Or did you actually have a class, Highlander, where you went and did this? We've been doing university courses on logic and geometry. This looks way more advanced than the stuff we were doing. We were just doing the basics. Yep, I like that. But again,
triangle and spherical geometry, all angles sum to more than 180 degrees.
Yeah, right. Well, see, again, I'll give you a...
That's not a triangle.
Well, that to me, because I know there is a proof that triangles have 180 degrees, that would prove to me, I would need some other to find the definitions of spherical geometry. So in Euclidean geometry, it says a triangle has straight sides, 3 straight sides. And then it also has the definition of a rectilinear angle in between 2 straight lines, and that's what it is. So where is the definition from your geometry? Because I could get you the ones from my geometry. Because what that would seem to say was, if I have a proof from my mathematics that you can't have that, then whatever it is that you say you have got cannot be from the same mathematical system that I'm using, right? Otherwise, you'd have to have a proof. I mean, do you have a proof for the triangle?
This is stuff you learn in high school.
What? That triangles, there is a proof that triangles only have 180 degrees. Yes, that is. That's sort of high school geometry stuff. It gives you a foundation of mathematics that you can build upon.
But you learn in high school that when you draw a triangle on a sphere, yeah, in spherical geometry, that the angles will add up to more than 180 degrees.
Sorry, did you say when you draw a triangle on a sphere?
Yeah.
Like a ball?
If that's what you want to call it, yeah.
Well, that's a Euclidean shape. That's a Euclidean 3-space shape. In reality, it's a 3-dimensional shape. In reality.
Bev, do you still have that ball that you have the cutout of?
Yeah, of course I do.
So we don't.
I don't think Highlander would understand it.
Show him.
I mean, I kicked a ball around a lot as a young kid.
Yep.
So I know that shape is a real shape.
Yep. It absolutely is.
And I remember distinctly that one of my Nike footballs was actually made up of leather triangles.
Triangles?
One was made up with leather hexagons.
Uh-huh.
I think the shape was. But yet you wouldn't say they were hexagons or
That's
triangles because they're not straight lines.
That is
because they're spherical.
Hexagon. How many sides has a hexagon got?
Is it 5?
I don't know. Is there a definition of a hexagon in spherical geometry? I'm not so sure. Have you ever seen a square? Actually, no, that's silly.
I'll see if I can get a picture over there.
I know what a ball looks like, Highlander, and that's why I said when you said draw, you know that the surface of a ball is curved, don't you? Highlander.
Yeah.
Right, so a triangle. Can you make a triangle out of 3 circles? Is that... I mean, it did say... It says 3 straight lines in Euclidean geometry.
To me, this football has a triangle on it.
Where?
In between the stars, can you not see the triangle? That's a triangle in spherical geometry.
Yeah, but like I say, to make a triangle, you need 3 straight sides. On that thing that you've got there, it seems like you've got 3 circles. So in spherical geometry, do you think you can make a triangle with 3 circles rather than 3 straight lines?
3 circles?
Yeah. That's not what that is what you've just done. You see that picture that you've shown us, right?
Yeah.
So it says lines in spherical geometry. It's got circles. There's 3 circles there, isn't there? So are you saying that all lines are circles?
No.
Oh. Well, you're not saying a circle is a straight line, are you?
Are you talking 2D shape or 3D shape?
Whatever shape you want to imagine. Is a circle a straight line?
See on that picture on the left hand side,
Yep.
right, where
Three
the
circles.
circle and the two circles on the inside, yeah. If you
That's
were to
3
rotate-
circles.
Yeah, if you were to rotate that to
Yep.
the point where you don't see, you know, that inner circle.
Yeah, the
the
circles.
two-
They'd still be
the
circles,
back-
though, wouldn't they?
the
You
back
can't.
of the circle
You can't
will line up
rotate
with
a
the front.
circle to make it a straight line, can you? I mean, that does sound a bit. You're not really suggesting that, are you, Highlander?
No,
Please.
that's a sphere.
Yeah.
So these would be lines drawn on a sphere,
A circle.
right? But if you look at it
A circle.
at a certain way, it would just look like a straight line.
Yeah, but you're
It's
not
not- it's not
suggesting
until
that
you-
you can rotate a
until you
circle
rotate-
to make it a straight line, are you? I mean, that would be ridiculous.
But again, it's just perception, then, isn't it?
Turn it. You'll turn it straight at some point with the circle. That's ridiculous, Highlander. Come on. Circles cannot be straight lines. Straight lines cannot be circles. You must admit to find yourself saying something as ridiculous as that must be. I don't know. I don't know. Whatever age you are at the minute, can you imagine that you would be saying that at some point, that a circle is a straight line? Or if you turn a circle a certain way, that it then becomes a straight line. If you turn a circle on a sphere, if you turn a sphere enough, you can turn the circle that goes around it into a straight line.
How many curved lines do you see in this picture?
That sounds ridiculous.
How many curved lines do I see in that picture?
Yeah,
None.
yeah, that's because there is none.
Yeah,
Every one of them is a straight line.
absolutely. So you definitely know the difference between a straight line and a curve. Are any of those straight lines that you said are in that picture, are they actually circles? Or
No,
are
they
they
are
actually
straight
straight lines?
But my point is, your perception when you look at it, you see curved lines.
No. See, the good thing about mathematics, and especially geometry, you don't give a fuck about perception. Like, if somebody was to say to you, what's 2 add 2? Would you get all pissy if they started to say, well, it depends the way you're looking at it? Depends on your perception of what you imagine 2 is. Hey, look at it a bit funny. Look at it. Turn it a bit before you do it. That would be ridiculous, wouldn't it?
You're dealing with direct numbers there. There we're dealing
Yeah,
with lines.
we're dealing with straight lines, right? Which are even more fundamental to mathematics than numbers are. But you don't seem to understand that. Somebody's told you, Highlander, and I don't know who. Please tell us.
Right. So that triangle on that football is not a triangle.
Absolutely, it's got a curved
and
lines on it. They're not straight.
And no matter what any mathematician says, we cannot calculate the angles of that shape, whatever that shape is.
Yeah, with spherical trigonometry, yes, you can. The angles will be measured between 2 plane surfaces, either on the inside or projected outwards onto a square on the outside. And the triangles that are made from the straight lines of the projections of the angles will have 180 degrees. Always. It's a mathematical proof. It's axiomated in the fundamental understanding of mathematics.
In spherical geometry, the angles of a triangle can never add up to more than 180 degrees.
What is your definition of a triangle, please? Highlander? We'll start with actually. Let's start with your definition of an angle. I'll just nip to the toilet, and then I'll come back and I'll put my camera on and show you me ball. Back in a minute. Well, it's quiet. I've lost me me quadrant. It does have a name. I don't know what it's called. There it is. Still here? Yeah. Ooh.
Yeah, I'm still here.
Right, have you ever looked into this, or have you just stumbled upon it? I mean, because you do say you've not told us who's told you this, where your authority comes from this.
I learned about spherical geometry in school.
Did you?
Yes.
What did he tell you?
Although it was quite some time ago.
Okay, here's a
Yeah.
ball. You've seen one of these, a ball. Now, can you see that? Would you call that a triangle? Would you call that a triangle?
Where have you posted it?
I-
The only thing I'm seeing is the
wait a
last
minute.
picture I
Wait a
posted.
minute. There you go. My camera. See that? Do you like it? Do you like me ball?
Again, where have you... All right, yeah.
On the video?
Yeah, that's got the hexagons on it.
Okay. What about that? What's
Yeah,
that?
but to me that's the triangle.
That's a triangle. But you can see it's got curved, right?
Right.
But that's not a triangle, right? Triangles have
Hold
three. We know triangles have three straight sides, right? Now,
Yeah, that's what you say.
okay, well, how would you measure those angles? Do you imagine? Do you know what the angles are?
No, I wouldn't know what the angles of that are because I don't know the dimensions of the ball.
What? The
I would
dimensions
need-
of the ball. It's a sphere.
Yeah.
Yeah. Do you know? There's no scale, is there? It's a ball. The dimensions of the ball don't matter. Because with the other one, with the triangle proof that I had, always have 180 degrees. Like it's a definite, always. Are you saying it's not like that? You can have triangles with different
What
more.
shape? What shape is that, Don?
Pardon? This ball?
What shape? What shape is that?
A ball? Are your mic's gone funny, Highlander? I can't hear what you're saying.
I was just asking my 8-year-old what shape that was.
The ball?
No,
Okay.
the triangle on the ball.
Okay, right. Now, well, what's this? Ooh, what shape's that? What shape's that? See, because this shape that we've took out of here is a piece. Well, look at that. It's a quarter, isn't it? It's just a quarter of the whole thing, right? So I'll put the ball down now for. Well, in fact, I'll leave the. Here's the ball. Now, this is where the angle was, but we can't measure an angle to a curve. What we need is. We need this, right? And then here's your angle,
Right.
right? So there's one angle there. There's one angle there, right? It's easier to show on this one. So there's your three angles: one there, and one there, measured in between these flat planes. In between the sides, two straight lines again, right? In order to measure the angle. It's better shown here. Right? You've got 90, 90, and 90. 90 degrees. Now, it's not this angle here, is it? It's this angle here, between these straight lines. Because you can't measure the angle to a curve. You have to either go inside to measure it, or you project the lines outwards onto a square out here, and that's where you measure the angles. So this is just a quarter, or an eighth. Right?
That's a tetrahedron.
What is
That.
that's
It's a 3D triangle.
Yeah, but there's that in spherical geometry there's no such 3D. There's no third dimension, is there? So you're screwed. You can't do that.
That is a 3D object you're holding.
Yep. This
And
is as well.
if we were to call that a
This
triangle,
whole thing is.
it's called a tetrahedron.
This is all a 3D object. With curved surfaces all the way around it. All the way. A surface of constant curvature all the way around. Yeah, watch this as well. This will be good. See that?
Right.
Two straight lines.
Right.
Are they still two straight lines?
Again, they're on a curved surface.
Oh, so it's a curved surface now. It's a curved surface now, is it?
The ball is a sphere. Yeah.
Yep. Yeah, it's a surface of constant curvature. There's no straight lines on the surface of a sphere, is there? Even when they were straight. You put them on here, they're not. Right? So this angle that you've got here is 90 degrees, isn't it? Oh, look at that. It's gone. Wait a minute. So it's not 90 degrees.
No.
But it is 90 degrees. It's perpendicular.
It is on the whiteboard, yeah.
Yeah.
But that's it on a 2D surface, not on a 3D surface.
Oh, so this is a 3D surface now, is it?
Well, obviously, yeah.
Okay. Thank you. Do you think you could have a surface of a ball that was a 2D surface?
No, because a ball is a sphere, and
Yep.
spheres are 3D objects.
Yep.
Yeah. If you turn it into 2D, then you're turning it into a circle. Yeah, which is a 2D object.
Yeah. Thank you. I can't remember what we were saying. Something about triangles being straight lines, but they can't be on a 3D surface, right? Because it's a surface of constant curvature. So we can't have a triangle on a curved surface, can we?
A triangle is a shape, yeah, with 3 angles.
Yep.
The lines don't have to be straight for it to be a triangle.
Yeah, of course they do. Look. Here's a protractor.
Right.
Right. This is 0 here. That's 10 degrees from there to there. Right, that's the inclination of that straight line to that straight line, the 2 radiuses. I'll give you a quick example, right? So we've got a pen here, right? So we go straight line, angle there, and then because the lines go out straight, it's the same angle, isn't it? Yeah. The angle, because these are straight lines and they can be extended indefinitely, the angle always stays the same. But the problem you have is when you have a straight line and then a curved line like that, because that's all a curve is, right? So you could have this angle here, a little tiny one, and then it's getting bigger, and then it's getting bigger, and then eventually you end up here, and so the angle goes to 360. Can't be right. That's not right. You're not ending up with the same angle if you have an angle to a curve.
Yeah, but you just drew a circle next to a straight line.
It's a curved line.
It's
a curved line.
Right.
Yeah.
So what happens if you draw 3 curved lines that meet up like a triangle?
See? It's a curved line. An angle to a curved line. Yeah? Well, okay, then if I do, like say like that, whoop, and then, whoop, and then, like that, 3 curved lines. Oh, it's gone. Can't. Well, here it is. I'm gonna scare you off with a water level on the drawing board. So, if we have an angle like that, then, what we'll do is we'll curve one of these lines here. No need to go too far, is there? Because like you say, it doesn't matter how far it curves. Now, in order for us to have this curve, yeah, actually, you know, I've got a good one for you. Like, if you imagine your one.
You almost had it there.
Right,
All
well,
you
okay.
had to do was draw another curved line from the bottom of your first one to the straight line. Yep.
Like that?
Yeah.
Right, so where's the angles? How do we measure the angles for this triangle you've got here? Well, it's not a triangle, is it? So I don't know, what would you call that, a triangle? We'll put it here, right? This is the point there, and there. There you 3 points, right?
Mm-hmm.
Now, how would you draw a triangle?
So to me, that would be a triangle.
Where would you measure your angle?
That's 3 points.
Where? Here?
That's where you would measure the angles. Yep.
Right, so let's say this one looks like this. Right, where do we measure the angle? Here or here? Because we need 2 straight lines. So do we do that and then measure that angle there like that?
No, you would measure where the 2 curved lines meet the 2 straight lines. That's your angle.
The 2 curved lines here, but you need 2 straight lines in order to measure the angle. See, because I did this before. Are you going to say, is that the tangent point? Are you having the tangent point of the curve? Or do you want the centre point of the curve to be your tangent point for your straight lines to measure your angle? You've got two
No,
choices.
Your tangent point would be where the curved line meets the straight line.
Where what curved line meets a straight line? You've not drawn any straight lines. We need a straight line. That's the tangent point.
You did on the image above.
Like, yeah, right. So you've got two choices, right? You've got, look. You've got a tangent point here, like that. And then you have to have one here, like that. And then you have to have one here, like that. And then one here, like that. And then one there, like that. And then one there, like that. Right, so you've got this angle here, like that. This angle here, like that. And this angle here, like that. Yeah? There's your three angles. You happy with that?
Pretty much, yeah.
You know, you've got 1, 2, 3, 4, 5, 6. You've doubled up on your sides. In order to get your angles that you needed, you've now got a 6-sided shape. That's a bit tricky. Because you've gained another angle here, and another angle here, and another angle there. You've now got 6 angles and 6 sides.
But why are you working out?
It's quite impressive. Angles? What?
Why are you working out the angles?
Okay. What we'll do then, put the other one here. Put this angle point there like that. And then that. And oh, now you have got 3. You've got 3 angles there now. With the proper triangle with 3 straight sides. One comes from here to here, like that is, isn't it? And one here to here. Oh, no. That like that, there to there. Yeah? Triangle. 3 straight sides. Who's been telling you this stuff, Highlander?
It's just what I learned in school.
You learnt this at school?
Yeah, I thought most people did.
Was it after they told... How old are you, Highlander?
41.
It's the whippersnapper. They didn't used to teach you this in... You must have gone to some high grade stuff. Did they did teach you that triangles have a... There's a proof for a triangle only having 180 degrees, right?
No, they never said that it was a proof that triangles have 180. They said that the inside of triangles added up to 180 degrees.
See this? It says if a straight line passing 2 straight lines on the side of this side here of this line with the 2 that add up to less than 180 degrees, right? Less than 2 right angles. Obviously this side, less than 2 right angles. If extended indefinitely, these 2 lines would meet, wouldn't they?
Yeah,
right?
If you extended the lines, they would eventually meet, yeah.
Yeah, and that's because whatever this angle and this angle, A and B, right? So we've got 180 degrees less than minus A and B equals
angle C.
Over here, C. Yeah?
Yeah.
That would be because this triangle with 1, 2, 3 straight lines add up to 180 degrees. It's axiomated, isn't it?
Yeah.
Yeah.
I mean, I'm not saying that that's not the case.
Okay. You're
Right.
just saying you can think, or somebody's told you that an axiomated something like that would not be true, right? You're allowing for something like that to not be true, even though it's axiomated. You can quite happily go against that because somebody taught you when you were at school that that might not be true. There's certain cases where this can occur and that not be true. You think?
No, that's not what we're saying.
What's not what you're saying? What are you saying then?
Right. And what I'm saying is, in spherical geometry,
Yep.
the inside of the angles of a triangle will add up to more than 180 degrees.
Okay, so
We're not saying that the insides of a normal triangle don't add up to 180
okay, but
degrees.
I'm saying a triangle in reality, right, as proved by any trigonometrical triangulation in reality, triangles have 180 degrees. Now, with you saying in spherical geometry that doesn't occur, are you saying that in spherical geometry isn't reality? Because this definitely occurs in reality. I can prove it to you all the time. Anytime. Within maths.
But you just drew a triangle on a sphere, on a ball,
I didn't.
and I guarantee if you work out the angles of that triangle, it will add up to more than 180 degrees.
Dude, this is a ball.
Right?
Right, well, it's a 3-dimensional shape.
Yes.
And as such, has a surface of constant curvature. And a triangle is made up of 3 straight lines. You cannot have a straight line on a surface of constant curvature. Right?
It's a triangle. It's
not. It's not a straight line.
How else,
It's not a straight line. I'll give you Euclid's Elements again. It's a good book. You should get yourself one of these, right? They come in handy. Definitions at the beginning. It says rectilinear figures are those which are contained by straight lines. It's number 20. Because you know what rect is? Straight, right? Rectilinear figures, those contained by straight lines. And then it goes straight onto it. Trilateral figures or triangles by 3 straight lines. Well, that's 3 straight lines. It's in Euclid's Elements. I mean, everybody knows it's high school, junior school, right? Elementary. What's the first shape you learn? I'd say it's probably a triangle, right? Does a triangle come before a circle? Nah, it doesn't, does it? Circle comes first. Because it's axiomated. Circle. How many straight lines? How many lines does a circle have?
Yep.
Do you know? Here's another one, Highlander. Since a triangle has 3 straight sides, you know, it's also an axiom that two straight lines cannot enclose a space? Would you agree with that? I'll say it again. Two straight lines cannot enclose a space. Would you agree with that?
There's the triangle you just drew, where the triangle on the inside of it.
What? Are you putting something up for us in debate discussion?
Yeah. It's called a relux triangle. I don't know if I pronounced that.
Yeah. A relou. I think he's a French guy.
Yeah.
Yeah.
But the outer shape is still classed as a triangle. It's just that the sides are curved.
It's not a triangle. That does have straight sides on it, right?
Yeah, the inner triangle does, yeah.
Yeah. Well, it's a triangle then, isn't it? If you've got three straight sides, then that is the very definition of a triangle. That one's called a relou triangle. Relou, I don't know. I'm not very good at that. Because it has like circular discs around the outside of the triangle. Right, so the bit on the outside that's curved, you wouldn't call that a triangle, like, would you? You did just call the actual triangle a triangle.
But yeah, I would say it was, yeah. It
Right,
holds the basic shape of a triangle.
The three straight lines in the middle.
It's yeah, to me that's two triangles, one in the middle and one on the outside.
But one of them's curved and one of them's straight.
Yeah, but they're still both triangles.
But a triangle only has straight sides, right? The very definition of a triangle is a rectilinear figure bounded by three straight sides. Those ones that are curved aren't straight.
Yeah, it goes on a wee bit more. It says relou triangles have also been called spherical triangles. So that term more properly refers to the triangles on a curved surface of a sphere. Yeah.
That's a spherical triangle then, not a triangle, right? I'll take the definition spherical triangle being different than an actual triangle, but please don't try and confuse the two. Like a triangle has three straight sides. A spherical triangle could be what you call three sides.
Why?
Yeah, three. It would be three portions of circles, wouldn't it? Because you have to sort of redefine straight as well, don't you?
It's still a triangle, even though the term itself is a spherical triangle. It's still a triangle.
Well,
Just because
actually,
I don't call an obtuse triangle an obtuse triangle and I just call it a triangle,
yep,
it doesn't mean that I'm wrong.
Can you tell me what a spherical angle is then, please? Where's your definition of a spherical angle?
It's an angle where two lines meet on a curved surface.
That would be at the point of tangency, two straight lines, right? You have to make a tangent point in order to make an angle. Like I keep saying, straight lines.
Two curved lines can't make a tangent point, no?
Two curved lines cannot measure. You cannot measure an angle between two curved lines. Very true. You need to have a well, actually, no, because you can't, can you? In spherical, is there any such thing as a tangent in spherical geometry? Have a quick look. What do you reckon? Highlander, what do you reckon? Do you reckon if you were to look up spherical geometry, is there a tangent in spherical geometry? What do you reckon you'd find? Can you have a tangent to in? Is there a tangent in spherical geometry? You think it's possible? But you did you said earlier you didn't even think it was possible for it to be 2D.
If you draw two circles that touch at a certain point, then that would be your tangent point.
A tangent point of. Do you know what a tangent is?
A tangent is a straight line.
Do you
I don't know if you can hear me or not.
Yeah, we can, Rob. Yeah.
I just left work. So I figure I could jump in now for just a quick second. Highlander, it's nice of you to come in and chat with us. I just want to thank you for that.
I second that.
Am I still there? You guys hear me?
Oh, I can. He's just putting the kettle on.
I can hear you, Rob.
No doubt he's looking up for it if you can have a tangent in spherical geometry.
Well, maybe in spherical geometry, but aren't we dealing with reality here? And in reality, most of the time we deal with Euclidean geometry. That's why all other forms of geometry are called non-Euclidean. Am I right or am I wrong?
You're dead right.
Isn't he
right, Highlander?
I'm pretty confident in my abilities.
He is right, isn't he, Highlander? I'll agree with you there, Rob. He'd be looking he's looking for a tangent to a two-dimensional.
Yeah, but when they say tangent point, they think they've got to win. Do you know what I mean? Because, yes, there is a point as part of that tangent, right?
It's a tangent point,
the tangent, the straight line in relation to a circle. And where they touch is a point. But the tangent is a line, not a point.
Yeah. And where would you draw that line at the point? I mean, that's a tricky one, Highlander. Where you just had two circles meeting, and then you had them meeting at a tangent point. Well,
that's not a tangent point.
Yeah.
That's just two circles meeting at a point. What would you call that? Two circles touching at a point. That's not a tangent point.
Call it the intersection of two circles?
Well, no, because they're not actually intersecting. They're just touching at a point. Right?
I don't know.
So I would call that a point of contact, but I wouldn't call it a tangent because a tangent is a straight line touching a circle at a point.
Right? Is that still not a point of contact?
What are you talking about, Highlander? I'll put the camera back on and I think we'll have a go at that.
Is your tangent line when it touches the circle, is that still not a point of contact?
Yes, but you need a straight line to be called a tangent.
Here we go, right, here we go. Here's a straight line. Boom. Here's a straight line. I'll move that over there. Right, and here's a circle. Are you happy with that?
Hold on. Yeah.
Right, so where's the tangent point? Here. At the point where it touches.
The point where it touches the circle, yeah.
Where's your angle?
My what?
No, I'm talking to Highlander. He's talking about an angle. How do you get an angle from a point? Because an angle is the inclination of two straight lines to one another. Well, you've got a tangent, which is one straight line, and then you've got a point where it's touching a circle. So where do we get the angle from, Highlander?
I think the mathematics it's a bit beyond me, to be honest. It's
Right.
yeah, I'll show you.
Who's told you this then? Because this should be quite easy. You should just be able to go do the angle there.
I mean, it's I can follow most of it, but it's pretty advanced stuff.
Yeah, it starts getting crazy when you start trying to put a model of your beliefs into it that doesn't comport with actual geometry. You understand? When you're trying to create your world as a sphere spinning and flying through a vacuum in outer space, then none of this geometry makes sense, because this is all reality geometry that we deal with. So we don't try to put this geometry on a ball. Do you get what I'm saying?
Did you see that last two things I posted?
No, sorry, I'm driving.
Yeah, there are loads of really big numbers that you yourself have said. Can you look at the board and tell us how you imagine, where would you measure the angle? Here. You personally. I know you think some mathematicians will be able to give you an equation or something, but just actually physically measuring an angle, where would you do it, Highlander? Would you do it here, where it's touching? Or would you do it over here, where it's obviously a lot bigger? Or would you wait and do it like over here? And how would you do an angle to a straight line? You couldn't. There's no such thing. There's no such thing as an angle to a curved line from a straight line. It doesn't exist. That's why I was asking you who it was that's told you can do this sort of stuff. Or is it you've just imagined that you can do it yourself?
The two things I've posted is from a paper that is called Measurements of Curvilinear Angles, yeah, which is the angles of two curved lines which meet. Yeah. Okay, I admit that
we need to define angle then. You got a different definition of angle than we do then. Right?
This is what we call a protractor for measuring angles.
Definition of angle. And angles where two lines meet.
Yeah, two straight lines.
Straight lines.
Was that? There is. I mean, what other definition is there?
There is none. Straight lines.
Well, you invoke some curved lines creating an angle.
But according to you, to have an angle, that two lines must be straight.
Yes.
If they're not straight,
yes, look.
They're not.
Can you see this? This is a protractor. Have you seen protractors before, Highlander?
Yeah.
You have seen how, right. What they do is they get a circle and they divide it up into 360 degrees. And then you take a line from the centre point of a circle and you measure the angles or the distance around, and that's what the angle is. It's a number of how many of these intersections you are away from your starting point. So you can imagine this here as being one corner of a triangle, because it's just an angle. Straight line, right angle. Here, here's the correct angle. Right, a device. You must have seen these. You'll never get one of these bent, will you? It can't be the right angle. It would definitely be wrong, wouldn't it? If you were to bend either one of those. All right angles are equal. Unless it's mine. Unless it's a Nug Life one, and then it'd be a super duper angle. Definitely much better than all of the rest.
Yeah, but two curved lines can't create an
Two curved lines can't create an angle, you're right.
Shout out to Nug Life.
Yeah. Look. Angles. It's a big magnet. So you can't, literally you cannot do it. Only straight lines. I mean, I get your team out, Highlander, if I were you, and because angles are between straight lines. Even when you're measuring them, when you're triangulating your position from the top of a mountain, looking out. Straight lines. One angle, I'm looking and I'm turning there. It's the inclination between that straight line and that straight line. They call them azimuthal angles.
When y'all get together, Highlander, would you mention Nugget Lives Matter for me? I appreciate it.
In the General Globe Defender Council meeting.
Yeah, hey, I just wanted to say something about chicken nuggets. To be honest, my daughter, she loves chicken nuggets. She will only eat chicken nuggets from McDonald's and French fries.
Well, they must be good.
Shout out to the Nugs. Free the Nug.
We'll just count her as a all Nugget Lives Matter supporter then. Thank you.
So we got somebody with the camera on. Does everyone know? Who is it?
Rob Keane, got a camera on? Oh. Yeah.
Nugget. Live nugget eating.
Yeah.
In that paper that I showed you, it says if we have three circles tangent at the same point, right? So.
No.
Do you know what that means?
Yeah.
Three circles tangent at the same point. Have you seen the test, Highlander? What I've been showing, the straight line test. Brew time. Have you seen the test?
What's that?
Highlander, the straight line test.
No. Hold on. Give me a couple of minutes. I just need to run to the toilet.
Okay. Well, everyone all right with us going over this straight line? I go back to the old school one because I think the 400.
Might want to bring some tissue back with him for them tears.
What kind of crap is he posting over here?
Have a read of it.
I can't even read it. I think I'm blind or something. It's just all blurry.
Try and do a good job of this one. So can anyone get the understanding of why somebody would want to have an angle to a curve, right? Why would somebody imagine that they can just do that?
Can I answer that?
Yeah, I know the answer, but I won't do it.
Go on.
Come on, Cleary. Can I?
Yeah, go.
Because I have a belief in a model that is my reality. Or something like that.
Yeah, but why would you need to have an angle to a
Because
curve?
I need to defend my model.
Yeah.
This just so we're clear, it's not actually my model. I don't defend any models. I'm just saying that if somebody believed they lived on a sphere spinning in outer space in a vacuum, they would need this straight line to touch a curved line. And they call it a horizon or something.
Well,
I don't know. Maybe Highlander or Cleary could do a better job than me. I fucked that up.
Well, it's always, and I've always found it a bit strange, right? Because you've got a guy, usually DP, looking out to the horizon, right? So he has an auto level that does that, sets a horizontal, and then he looks and he measures a drop, right? There's an angle there. There's still two straight lines. So he's not defending an angle to a curve there, because that's the angle at the point that you're looking. It's two straight lines, one straight line to another. So he has no need for that. There's no need to defend an angle to a curve there. The only reason I can see that somebody might want to defend an angle to a curve is because somebody's gone like that. You can draw a triangle on a sphere. That's it. That's the only reason I can see that they need an angle to a curve. I think it's personally because Wolfie's told them he can get his plane and he can fly his plane and then turn 90 degrees and do that again. That's the only reason they need a triangle to have, when it's obvious that it's constant curvature. Even Highlander had a surface of constant curvature. That's the only reason I can see. Anyone else can see any other reason why anyone would ever want to defend an angle to a curve? I've thought about it. I can't think of where. I mean, let's say they're measuring an angle to the stars in the sky or whatever. Well, you get from horizontal, angle up. Horizontal is a straight line. Angle up is a straight line. There's no need for anybody to have an angle to a curve. And yet, people defend it.
I would say that triangle looked weird from the side. Like, it doesn't matter which way you look at that triangle on that ball that you just showed. Even going, if you want to call it the horizontal, if you can still tell, even just looking at it, you can tell that there would be a major curve that you would have to go over. Let alone the two fucking ones that you go up. You can definitely see those curves. Point is, all those lines are curving.
Even Highlander said it's a three-dimensional shape. He doesn't quite understand. They think, a lot of globe believers do this, they think that you, just because spherical geometry is the geometry of the two-dimensional surface of a sphere, they imagine it's the spherical geometry on a ball. Well, it's not. A ball is a three-dimensional Euclidean shape. That is not the thing that spherical geometry is performed upon. It comes as a big surprise when they find out that, well, not so sure they've actually found it out yet. Are you back, Highlander? Have to sit down for a bit while we wait. Oh.
Quite a crew in here today.
Yeah.
Did you see the crew over at Jose's? Holy cow, it's huge too.
Oh, really? They still going?
Yeah.
Yeah, but yeah, there's a lot of different people over there.
I'm glad I'm over here, I'll tell you that much.
Yeah. You could go and learn about the luminiferous ether.
Oh, fuck.
Open original.
Well, actually,
It's all of Jim's trolls there. They're all
Yeah,
there
really.
because they don't have nothing to do at Jim's. It's all of them. They're there.
You're right.
We're about to know.
Here we go. A curvilineal angle. And more, right. The introduction of section 1, we suggested UF1, some sort of a thing, is a more or less geometric way of defining a measure for curvilineal angles. However, we proceeded in a different analytical way. And in order to do some arithmetic, we only considered curves satisfying some differentiability conditions. Wow. So actually not geometric. They went into analytics and differentiability. So not actually calculations yet. Polynomials, yeah. It's all just calculations and stuff.
Yes. Well, that's what I was saying
and
at
pre-swimming the ball.
Reality geometry. Mayhem. Mind experiment.
I've just been through that stuff that Highlander posted, and all it talks about is assertions and theorems.
Yep. Yeah,
That's
and
all
calculations
but,
and differentials and...
Yeah, it gives a couple of definitions, but it's not axiomated. It's just theoretical and assertions. Somebody's opinion.
I couldn't even read it.
It was
weird. Go ahead.
I don't think a lot of these people understand what axiomated means.
No.
Like the step-by-step process. They just believe what they were told when they were kids. They had a little globe in their classroom, and they say, "You live here." Okay. And we'll just carry on with our lives.
Right, here we go. I've got one for you. John Wallis, 17th century, published a treatise on the angle of contact, i.e., this might sound familiar to you, DP, the angle, and Mobius, the angle between the curved line and its tangent. He asserts that the angle of contact is no magnitude and not any part of a right-lined angle, but is to a real angle, whether rectilinear or curvilinear, as 0 to a number. Sounds a bit fancy for saying it's nothing. It's a not angle at a point.
Magnitude.
Yeah.
Yeah,
That
so
of which has no parts.
It's actually no angle, though.
Yeah, it's a 0.
It's actually got no angle. But
Yeah, but
you can make it look like it's got an angle.
But according to some people, a 0 angle is still an angle.
Yeah. That's what he's got. To some kind of magnitude, they are nothing. Right? Like magic trick. To some kind of magnitude, they are nothing. Yet they are in the possibility of being somewhat and the beginning of it. For instance, a point is in the next possibility to length and inceptive of it. And the same applies to an angle of contact. Right? That's bullshit wizardry. Saying nothing. Even talking about nothing. Man.
We're stupid and you don't understand.
No, I'm going to have to get that.
See, people see this stuff and they look at it and they read through it and they think, yeah. But they don't actually read the words that are written.
Yeah, here we go. I'll put it in the debate discussion. See whether you can read that any better. There you go. That's even better, right? That's that stuff that they've been coming up with, right? It's an angle at a point is nothing. It's not there. It's because a point's not even there. So the angle's not there. But they can say that's the start of an angle. You've got to start somewhere.
Is it in free space?
Mm-hmm.
That's all
Absolutely.
Free space, not free space.
Free space, yeah. You can only have an angle at a point in free space.
Yeah, that's right. Boy, that'll be confusing for people. Did you say free or 3 or what? Well, if it's bullshit, we said free.
Yeah.
Is that 3 or 3?
Free. Like James Brown. Type of free.
Free James Brown.
Yeah, I guess you gotta be an American to get that.
That was
Hey,
old
guys,
school,
it's been
man.
hanging out here, but I gotta go for a bit. I might come back.
Catch you later.
We'll probably be here.
Yeah.
Somebody will. Even if it's just turn up.
Redmond sleeping on his mic.
Yeah.
Everyone all right with the camera on there? I want to keep it on for
Yeah,
Highlander when he comes back.
I'm wired up.
I want to do the straight line thing.
That's got some problems if he's dealing with spherical geometry. Straight lines might throw it for a loop.
We need to find a way to get the 2 straight lines cannot enclose the space. Right? Because you always hear them dodging that.
What do you like? Want a meme for it or something?
Yeah, we need to bring it back out into the forefront, and we need a surefire way of entering it into the conversation, don't we? How do we do that?
It's the chopstick paradox.
What about if we fit it into the triangles have 180 degrees, and an angle is the inclination of 2 straight lines, and 2 straight lines cannot enclose a space, can they?
No.
Type thing, right? Always
we could have
get
examples
it
for
in
each
there.
one.
Yeah, on your way to 3, right? Every time when you get into 3, because we like the word 3. When you get to 3, before you get to 3, mention 2. Every time you hear the word 2, you've got to follow by, and 2 straight lines can't enclose the space, can they? Can they? No. It's almost as stupid as
I should go to the store and say, yeah, I need to enclose a space, and I just want to buy 2 2x4s. The guy literally would be like, you're going to need at least 3. Maybe 4. Do you want to make a square? No, I just want 2 straight lines enclosing a space. You want to cut the pieces? No. Oh, that'd be funny.
Let me sell you some warped ones out of the discount bin.
A globe head will do that. You watch. Yeah, I think you could talk to these globe heads for 100 years. They'd still be like, it's a globe.
Yeah, it's definitely more psychological now, though, right? You know, you can see it within the argument or within the conversations that you're having. That you can, there are certain mathematical statements you can make that you don't really need to over defend. That you can make especially the ones that have learnt the argument, right? The ones that are clever enough to know the argument for their model. You almost know where they're going. I mean, Highlander's not too clued up on it because he's made a couple of mistakes, bad ones.
Yeah, that guy earlier thought he was so clever. I was just like, dude, you think you're special, but you're doing the same thing everybody does.
Yeah. Avoid.
So predictable.
They avoid and don't answer. And when they do answer, it's from reality. But any answer from reality goes against their model. Even Highlander thought he got away with a couple of them. But he didn't. He's falsified his model a couple of times.
Oh, yeah. I was saying that to the trolls over there in Brandon's a while ago. I said, trolls live in text, and they die in voice. That's where they live, right there, text.
That's what makes them text chat trolls, is the fact that they have been destroyed in voice. They can't go, they know they can't go back there. Because it's already happened. Yep, Rumpus, Zanuck, Ruhif. They could all team up and come together, but they won't. Because they know if they ever team up together, they will contradict each other. They always do. Ruhif says level is horizontal. Rumpus says horizontals are parallel. He's probably changed his mind by now.
Oh, yeah, certainly.
But yeah, we all know there's a couple of things now, geometrically, from reality, destroy the model. The triangle, horizontals being parallel, 2 straight lines can't enclose a space, and the fact that there's no vertical. That's a big one, right? I don't know when we're going to get to that. But 0 elevation change to them, what they haven't realised yet. Highlander, are you here? Are you back?
Yeah.
You want me to give you all your secrets away? Because you imagine elevation changes above, measured vertically, don't you? You know, on the spherical geometry, there's no vertical height, so you fuck for that for starters. The fact that it's perpendicular also screws it, because that's 2 straight lines. You have to imagine. I'll tell you, Rafa, now. Are you keen on bendizontal being a thing? Like a bending horizontal lines?
I've never heard of that term before.
No. Well, get ready for it, right?
Why? Who's using that term?
Bendizontal.
Yeah.
That's your only way out of this argument geometrically.
How is that my only way out?
You have elevation is a measured change in the vertical height, right?
Above mean sea level, yeah.
Okay, so mean
Average
sea
sea
level is what? A straight line, right?
The average distance between the center of the Earth and the fluctuation in sea level.
Okay,
Like
so
at the equator or somewhere else? Like 22 kilometers higher at the equator or somewhere else? Sorry, go ahead.
yeah,
I'm
mean
not
sea
quite sure
level
where.
would be a straight line, right?
Mm-hmm.
Like a measured distance above that would be perpendicular, right? You would measure perpendicular height from the surface vertically, which would make the shape at the underneath that you're measuring vertically from a straight line, right? Have you ever seen an elevation map of anything? I've got one.
Yes.
Oh, actually, did you see that thing that you got where it said an angle is nothing? An angle to a curve. Yeah. So that's nothing. So like 3 of those would get you a triangle with 0 degrees. I mean, that doesn't sound like much of a triangle to me.
You do know that part that you highlighted
Clipped
is from
out.
a paper. Is from a paper that somebody else produced
that you give
years
us
before.
Yeah.
Right.
Yep. Yeah.
And in the paper I showed you, that section that you have highlighted, right, is a section that they talk about from someone else's paper.
Yep.
That was produced.
A treatise on the angle of contact. Yes. Are
Right.
you saying the angle's different? Has it changed?
Right. That section that you highlighted, right, is a section from John Wells from the 17th century. That's what they're talking about in that paragraph.
Yep.
Right.
And you do realise that the whole thing that you posted in debate discussion, Highlander, is just assertions and theorems.
Right.
There's nothing concrete in it.
Hold on. What is a theorem? Please tell me.
Bloody hell.
Go on. What is a theorem?
Something that can't be
and
proven.
It's not a theory before you.
No, a theorem is. It's a proof.
No, it's not.
Right? It's what gets proved, right? So if you have you got the proof to go with the theorems?
A theorem is a proposition not self-evident, but proved by a chain of reasoning, a truth established by means of accepted truths.
Yeah.
Right?
Proposition 30 is a theorem.
It's proved by using things that are accepted proofs.
Yeah. Right? Here, Proposition 30. I'll read it out for you so you can hear what it sounds like.
It's not a guess or a theory.
Yeah. Proposition 30. Theorem. Straight lines which are parallel to the same straight line are parallel to each other. It's one of the best theorems we have. And then it goes through it and it comes up with an answer, right? There's a proof for that statement, that theorem. It's a book of them, right? Because Proposition 30 is a theorem. Proposition 31 is a problem. Whereas Proposition 32 is also a theorem. It swaps and changes between them. Theorems, propositions, and problems. All get proved. So have you got your proofs for anything in there, or is it just like DP said, assertions and theorems without any proofs?
Theorems are proof.
Where is it then? Where's the theorem? Because there seems to be a load of calculations and stuff in there. It's analytics. and differentialisms, not actual geometric proofs of any of this stuff. Like he said, that guy, they're stating the assertion that he made about the angle of contact being an angle of 0. So is that the angle that you were talking about? The angle at a point of tangency? That's what he's talking about. It's 0. It's nothing. No magnitude. It's not even there. This is what you've got to be very careful with mathematics. You let people take you away to places and then read the words and not really get a grip on what they're talking about. He introduced the idea of inceptive quantities. What does that mean? Somebody just, I don't know, let's have an inceptive quantity. What's that? Well, it's a 0 number that we start off with. So we can have an inceptive quantity of 0 because that's where we initialize the reading from. So the angle of 0 is the starting angle, and we build from that. That's what this guy's saying. I mean, it sounds ridiculous. I mean, Euclid did say that a straight line, an angle, is the inclination of one straight line to another. That cannot be the same straight line. Actually, so he said you can't even have an angle of 180 degrees. Because that is the same straight line. It's not even an angle. It's just a straight line. There's no vertex point. If you've got a straight line, one straight line, there's no vertex point that you can put to have an angle. But, I mean, other people have different concepts.
It would have to be at least 1 degree off that 180 for it to have
an angle, but you just called it 180. Right? Whereas Euclid wouldn't have let you say that. He would just said that's a straight line. There's no need to call it 180 degrees. There's no need, because he didn't have numbers. He would just say it wouldn't be 2 right angles. You'd call it a straight line. There would be no need to add 2 right angles together to make a straight line, because a straight line's what's needed in order to make a perpendicular. It's more obvious than it is axiomatic, but since it is built on logic, it puts it back into your hands, rather than having some concept of somebody else. Even Dances with Fools, 180 is not an angle. He's right.
No, I never said it was.
There's only one angle that matters to us, though, with right line geometry, right? It's the right angle. All the other angles can just do one. Only the nugs have the right angle. That's a good one, that, right?
Yeah. Nugs, not hugs.
What was the other one? If you said 2 straight lines can't enclose a space, triangle has only 180. What was the middle one? Can't remember.
Horizontal. Horizontals are parallel, I think. But we've already got that one on, you know. But that one definitely, I think those 3 have got to be the 3 easiest arguments from geometry to give to anyone.
Which one? The triangle 180, the 2 straight lines can enclose a space, and what was that other one?
There was another one.
It's horizontal lines don't intersect, or horizontal lines are parallel.
Yeah.
Depending on which
parallel
one you
lines.
Want to give it.
Yeah.
I think you've got to tie it into horizontals, though, haven't you?
Yeah, that's cool. Yeah.
Right lines. Keep it on the right line. Right, Highlander, do you want to see a straight line proof from reality?
What do you mean a straight line proof?
It's like a realism proof from reality to prove a straight line.
I don't need you to prove that lines can be straight. I know lines can be straight.
What about then horizontal is a straight line? There you go. All right. Am I tempting you? Let me see if I can do it a teaser a bit more. How about a horizontal is a straight line above a point. Larger than a point. Like an actual straight line between 2 points. Am I tempting you?
Sorry, say that again?
Can I tempt you to a proof that a horizontal is a straight line of larger distance than a point? 2 points I'll give you. I'll give you a horizontal is a straight line between the shortest distance between 2 points. How about that? Is that good? Horizontal is a straight line. The shortest distance between 2 points.
Yeah. Yeah, that's right.
Okay. So I can't tempt you for a proof that you already know that, do you?
But horizontal to what, though?
Horizontal. Horizontal to, well, it would be obviously parallel to another horizontal.
Yeah, it would have to be.
Yeah. Because horizontals are parallel, right?
Because, again, depending on where you are and how you look at it.
Horizontals everywhere you go.
Mm-hmm. Always parallel.
Yeah, but if I draw a straight line across an A4 bit of paper, that's horizontal. But then if
I don't know.
If I turn the bit of paper, that then becomes vertical, does it not?
What, if you're turning it on a table?
Yeah.
Yeah.
No, it would. I don't know. It depends. Is the table horizontal? Have you leveled the table?
If the table would be horizontal.
Okay. Now, the stack of paper, would that also be parallel with the surface of the table?
Yeah.
Right, okay, then any line drawn on that piece of paper would be on a horizontal plane, wouldn't it? No matter what shape. And if you turned it, right?
What if I stand the paper on its end? Is it still horizontal then?
Would it be perpendicular to the surface of the table?
Yeah, I accept you can have horizontal lines, yeah.
Okay. So when you stood that piece of paper up, just to be more specific, because we do like to speak mathematically and be precise with what we say. When I just asked you, was it perpendicular to the surface of the table? Is that what you meant by stand it up?
Yeah.
Okay. So then, yes, it would be vertical if that was the case, because it would be perpendicular to a horizontal plane, would be vertical, wouldn't it?
Yeah.
So we do live in reality, right? We're of a good understanding. Do you want to see a proof that horizontal is a line of unlimited length? And how to extend that horizontal straight line in reality?
Well, I don't think I've ever come across anything that says that a horizontal line has any particular restrictions. That it can only be a certain length. That it can only be a certain distance from a certain point.
Oh,
yeah.
Dead
Yeah,
right.
Rumpus said it could be infinite.
Yeah, it is definitely infinite. It's a horizontal plane, is of infinite length. But I'm just asking you, would you like to see a proof for that, or are you happy with in your knowledge that a horizontal is of unlimited a plane?
Yeah, I'm happy with that.
Okay, so you don't need to see a proof?
No.
Okay. So if I was to say to you then, level is a straight line on a horizontal plane, you'd be happy with that? You wouldn't need to see a proof for such a statement?
No, I wouldn't need to, no.
Okay, that's good. I'd watch out. Don't tell anybody you've just said that. They might call you. They might call you names. I think you could be Team Nug now, though. I think definitely freeing up a nugget for you.
Nugs, not thugs.
So when... Oh, I don't know. Puts you in a bit of a...
Oh, hold on. Give me a minute.
Okay. You got an incoming call from... I was really hoping to hit the whiteboard there, but I mean... Didn't even want to see the proof. That sure he was of his knowledge that level is a straight line on a horizontal plane, that he doesn't even need to see a proof. He must have one of his own.
Sounds like a geometrist to me.
I'd be keen to see what his proof is. You know, how.
I wonder what his name is based on, though. Highlander. Is that based upon a vertical change from sea level?
Oh, he's gone. He's gone.
He got the call.
Yeah,
That was Rumpus.
I think, yeah.
Abort.
Did he just say? Did I just say the level is straight line? Did I agree to that? What the fuck did he do? He tricked me.
Get out of there! He tricked you.
I don't want to stop recording just yet in case he comes back. He might just be a released phone call or something.
Yeah.
You know, I had to go away for a second. But he does have a habit of disappearing, like awkward situations.
Well, every day is an awkward situation for a Clover.
Yeah, this one is definitely going out. There is... yeah, I'm going to have to put this one out. I've been... every time Highlander's been here in the past, he's got such a lovely voice, and he's so happy and, you know...
and wrong.
Compliant. Yeah, I thought... I can't really put all of those out because I quite like him. But again, he's sort of showing how you can be like really, really wrong, and so sure, because I think he just Googled some stuff.
Yeah. Being agreeable. But, you know, how they do. Well, I didn't mean that. No. taking me out of context.
Yeah. Do you reckon that would have worked, right? Because, I mean, I'm going back through the debate discussion and looking at it. We opened up with the triangle axiom and the triangle proof. He came back with hyperbolic.
Aye.
Yeah. To which I replied with the angels and the demons. Penrose. If you've never seen that, right, that's what happens when you go into the realm of hyperbolic geometry.
Yeah, anything's possible there. I remember that.
Turn into some weird stuff.
That was, Penrose, wasn't it?
Then Bloods backed me up with things about triangles having 3 straight sides and Euclidean 2-dimensional 3 sides, 180 degrees. He then returned with the curved line, straight line, angle, the angle between the 2 straight lines. And then he did another picture of some curved lines and a triangle with 3 straight sides, again, with an angle in between 2 straight lines. Then spherical geometry, circles. Circles making triangles. Fantastic. Then a triangle on a football with some stars on it. Picture of some straight lines that appear to be curves but aren't curves. A Rilou triangle which has straight sides and curved sides. It's a double paradox or whatever, you can imagine both whilst looking at one. And then angles to curves, which said 0. I don't know. Nice, DP. I think it means, though, for when it says 2 straight lines cannot enclose a space, you need to have a triangle, like an angle, rather than 2 straight lines.
Not parallels, right? Something that's trying to close on one end.
I think you could probably do DP rather than putting the 180. Let me just clear this now. I'll stop recording. Don't want to give them more.
I gotta say, you're totally blowing my mind right now. You twat.
How do we know the Earth is not flat?
We don't. It's flat.
That was
understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil.
Bitch.
You twat. I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Society. My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round. They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash.